Hey, this is Dave Baszucki. I'm founder and CEO of Roblox, and you're listening or watching Tech Talks. So today we're going to be talking about what makes up a second generation game engine, how it involves cloud, how we help users join instantly at high resolution. We've got the technical dream team here as part of Roblox. So we've got Varun Mani, we've got Sergey Makeev, and Tsvetan Tsvetanov. And we're going to be diving into everything streaming. We're going to be talking about Slim. We're talking about asset transcoding. If we look at the gaming industry for the last 10 or 20 years, there's a traditional way that all this 3D content gets in front of you. And there's some issues with this traditional way, because what we're trying to do at Roblox, join instantly. We're trying to have the same experiences run on a phone as well as a giant PC. We're trying to do this without any latency. And when we look at the way traditional games work, it's not quite the same, right? Like I can remember in my days, they were distributed on these things called floppy disks. But even today, right, we distribute games on big DVDs, I think. Is that fair to say?
Yeah, and I think that the key to it is it's all packaged together,
Yeah.
right? So whether it's a DVD or whether it's you're downloading a game today, it's coming as one giant package that you cannot split it up. So you have to wait until the entire 4.7 gigs or 10 gigs in some cases fully downloads before you can start.
Yes, and as Varun said, like for some games that could be like 20, 40 gigs, and you have to wait like for a very long time before you can start playing. And that's kind of, like killing this like flow, right? So because like you want to play, you have like maybe like an hour or 2 hours like after work, you want to play a game and then you have to wait like for 30, 40 minutes like while it's updates. And like pretty much that's much like my experience like playing any like.
So isn't that it's somewhat akin to what we've seen in video and movies? I can remember a time when movies were distributed on DVDs. And then I could remember a time with BitTorrent, for example, you would download the whole thing. And then finally we got to like, I go to my Amazon or my Netflix or my Hulu or my Tubi and I can watch right now. But I don't think that's quite happened in the gaming market yet.
Not yet. I think
Not yet.
We are the only one that are targeting that.
So historically, Roblox has worked that way, and behind the scenes, most people might not notice it, but when you go to that homepage of Roblox and you click play, you can join instantly. This is actually very non-traditional because when I'm on some very elegant gaming platforms, I've gone as high as seeing 200 gigabytes of a download occur before I can play. So we're already doing this instant play.
Yes, Roblox, as far as I know, is the only platform that allows this instant join and play.
The kind of like when you were talking about the video streaming, right? Like what are you actually doing when you're doing a video stream where I don't want to download the entire movie. I'm just downloading just enough of the movie in front of me, and we call that buffering. I'm streaming the movie, right? So, that's just in one dimension because there's only a time dimension there. That's the key difference here. That's what's hard about doing it in Roblox because it's a fully interactive 3D world where you have to stream in both instances and assets, which is kind of the basic building blocks of everything in Roblox.
And I would say this is made even more difficult because in the traditional video game market, I tend to see different versions of games on like a high-end PC and low-end mobile. And the way I interpret that is on high-end PCs where I can like download hundreds of gigabytes and have these really big complex assets. And on mobiles, it's almost like creators, I think, make a separate version.
Yes, so that's a very good point because like in traditional games, they have this process that's called like asset cooking. So they are preparing a very optimized version like of their assets like per platform. And if you think about it like from a more, like video streaming perspective, then, like it's like on DVD, the video was just encoded once, right?
Yeah.
So, but like on any streaming platform, they have like multiple encodings like for the same video. So it's kind of automatically fits your device. And all current games, they, they pre-cook like their assets like and ship a very specific version of it. So while at Roblox here, so we are able to generate optimized version of an asset per platform on the fly.
That's right. So hold that thought, right? Because a while ago, we had the vision of if you're a young creator and you make your experience, it can run in any language. we had the vision that it can run on any device, and running at various resolutions on any device. We're gonna dive into it. So traditional gaming market, packaged, either downloaded. We want to solve those problems of instant access, publish for any device, low latency, and all of that together. And so we're going to be talking today about is something called literally 3D and 4D streaming. We're going to be talking about contents in the cloud. We're going to be talking about something called Slim, which I think everyone's going to get really excited. And so maybe to dive in, Varun, first, a little vision on what is Slim and what we call Cloud Transcoding, and what's that all mean?
So if we take a step back, if you think about like our overall vision is we're trying to get to 10% of the gaming market.
Yeah.
The way we do that is to give creators complete freedom over what they build. And if you think about how we grow, there's kind of two dimensions. You could either do platform expansion, or we could do genre expansion. Platform expansion is how do we get the same content to work on any platform? So you create once, Roblox makes sure it works everywhere. And then genre expansions, we want you to create more and more impressive things and more crazy things out there.
And just so when you say run anywhere, literally, imagine something really big and crazy and fun, Grand Theft Auto, Red Dead Redemption, high-end console, running on 2 GB Android
and
phone.
everything in between, right?
That's right.
So beefy PC all the way down to 2 gig Android should just work without the creator having to do extra work. So that's the vision.
Exactly.
Cloud Transcoding and Slim are just two of the first steps we've started to take down that path.
Okay, so that's a bit of a teaser. We're going to explain what Slim is, and we're going to explain, I think you'll probably explain what transcoding is, but let's keep introing first, everyone. So Sergey, can you share a little of your background in engine optimization? One of the most fun things in the world, right? C++, assembly language, like SIMD. Can you share a bit of what you've been working on?
Yeah, I'm pretty much been working on games or game engines for my entire life. Doing those low-level optimizations, starting from the original Xbox and stuff. And when I first learned about Roblox, my mind was just blown away with this idea of a game created just once. Or not a game, maybe any experience created just once, and then it's able to run everywhere on any platform, on any device, without requiring any additional user input. And that's an extremely challenging engineering problem, as everyone can imagine, right? So, and that's required a lot of traditional optimizations like SIMD, multi-threading, very careful, GPU scheduling, all of that. But at the same time, there are some limit on how much we can scale on a single device. But fortunately for us, we always have our cloud, right? So, and we can offload some of this work to our cloud and help those devices to render more efficiently, to render bigger worlds. To a degree, when we can render some worlds that cannot even fit into a physical device memory, because they also exist on the server side, and server helps all the clients to render them efficiently.
Yeah, and so just as a highlight, I think part of the hint that we're going to be sharing underneath it is traditional game engines typically written C++, and you download all of the assets. But say a game you wanted to play was the entire world, for example. No one can put the entire world on a DVD. And so what you're really hinting at, and we see it already with Google Maps and other types of that, there's no way you can put all of that in the same place. And so part of what we're going to talk about when we say streaming is that same thing for games. And then Tsvetan, can you what got you to Roblox, and what was your background, and maybe a little bit of a hint of what Cloud Transcoding is?
So before joining Roblox, I spent my professional experience in 2 domains. One is 3D design and simulation software for architecture, construction, and mechanical engineering. And the second one was large-scale distributed computing, which I can apply my knowledge from both those domains into Roblox, because pretty much that's what Roblox is.
Yep. Let's jump over to streaming on Roblox and talk about it. So we know what video streaming is. Video is kind of a linear thing, right? I just need a frame after a frame. We send one after the other. Can you share what streaming might mean in 3D in real time?
If you actually look at what almost everything in a Roblox game today is made up of instances or assets, right?
Yeah.
Instance is kind of the structure of the world, and then an asset is the thing that's actually driving that instance for the actual content. If you think about streaming, it's about streaming instances and streaming those assets as well that you have to do. So if in a video stream, you just have one asset, that's the video. In Roblox, we're doing that thousands, 10,000 times over and over and over. So when you're saying instant streaming, you're just trying to stream in enough of the world around you, and you don't know what the player is going to do. The player might walk this way, the player might walk that way. You want to stream just enough or buffer enough of the world. And then in that world that you've buffered, you want to buffer the assets at exactly the right quality. So as Sergey mentioned, you have different quality levels for video. We have the same thing for meshes, the same thing for images.
So if we broke it down, would it be fair to say the instances are things we might be familiar with, a car, a tree, another person, a hill, something like that. And then the assets are the technical things that make up those instances. Like inside of those 3D objects, when we're all on a game, we have like blobs of triangles, we have blobs of textures. And so we're talking about picking which of those to really pull in at any time.
Yeah, and which representation of them. So as you're walking through the world, it's like the device is saying, okay, I want that tree, or I need that tree. That tree is made up of a bunch of meshes and of a bunch of textures, and maybe even in the future, animations, audio, so on and so forth. So then it's deciding, okay, based off of the position of that tree, the importance of it, how much screen space it's taking, I want the texture at high quality, I want the mesh at medium quality, and then the audio, maybe I don't need the audio yet, so don't hold off on the audio. So it's constantly making those decisions.
So in a way, this is a little like when I use a mapping program, I bring in just the little images
chunk,
of the map. We're talking the 3D versions of that, and interactive 3D components as well. Okay. And there's something really essential here. Behind the scenes, I would say our vision has always been, no matter what device or whatever you're on, we're trying to get the right ones in as quickly as possible. And sometimes we say we want to get them in as quickly as possible to maximize the human perception of magic. Like you're just, whoa, the world appeared for me. So Sergey, how do we pick and how do we sort what to load and what to bring in?
So yeah, optimization for perceived latency, it's very important, because as Varun just mentioned, we constantly measuring screen space area, how important that object is. And for example, if you see a tree at a very close distance, or you see exactly the same tree at a very long distance, those could be two different trees, right? So if you see it from the distance, you don't really care about fine texture details or something. So we can always fetch low resolution texture for the tree. You won't be able to distinguish between if it's a low res or a high res texture, because it's just very small on your screen. But on the other hand, we can fetch it almost immediately, because that's way less data. But when you get closer to the tree, we'll progressively fetch more and more data, and it will look more detailed. So you won't be able to see the transition, you won't be able to tell the difference, but you will be immediately able to see and interact with that.
And part of this is when I'm using either my 2 gig Android phone or my gaming PC, and I want to join something instantly, even though the internet is really fast, we don't have infinite bandwidth. Like we're trying to push the world through that pipe, whether you've got 10 megabits a second or 100 megabits per second, and balance what we push through there. And one way I sometimes think about it is one tree that's close to me can use the same information as 100 trees that are far away from me. And essentially, the 100 trees that are far away from me may have the visual importance as the one that's close, and we bring them in at different resolution. Like the one that's close to me is much more high fidelity than the ones that are far away.
Yes, that's exactly right. And the important point that you also mentioned is we're not only measuring how important that object is, but how much compute resource do we have, how much memory do we have, network bandwidth, everything. So we take into account everything that affect user experience, and that include performance, how much memory do we have, and all of that.
So we've talked about instances are like the tree, the assets are the mesh or the textures. Can you share more how they differ and what underneath the covers really we're doing with asset streaming?
Yes, for instance streaming, the server decides what is important.
Yep.
And based on the importance, it gives this information, pushes this information down to every client, and every client actually gets a different instances for that, depending is it visible, it's not visible, is it participating in the interactive part or not. For the asset streaming, it's the client that actually streams in what was in the world based on the quality that we are targeting, as Sergey said, based on the capabilities of the device. We are only targeting those exact representations based on the quality and based on the capability of the device. Pretty much that's how we are.
So those trees way off in the distance hopefully are very compact, right? A lower resolution, not taking a lot of it, so we can spend more time and more compute with a tree that's closer into me. And so we have this thing called the content pipeline or that asset pipeline. Can you share a little about, like, if I'm a game creator, what does this transcoding pipeline look like? I'm using Roblox Studio. I build a really nice car. What happens behind the scenes?
Because of the improvements in engine, we also wanted to preserve the artistic intent for the designers and game developers. So we came up with this idea of cloud transcoding that allows us to ingest the content from the creators, store it, optimize it based on the devices and capabilities that the client needs. And this pipeline is end-to-end. It is lazy on demand. What that means is that when the client requests a specific representation, only then, if we don't have that representation, we start a compute. If not, we return it if it already existed. So we are very optimal on the bandwidth and the compute that we are providing to the client.
So if there's a long time ago when we didn't have this, or maybe actually pretty recently, that we had to put limits on the fidelity of these assets. Like, I think we would say you can only have so many triangles in your car, and the more triangles, the more accurate your car looks. Or we would say you can only have so many pixels in the size of a texture. What we're saying now is, I believe, you can upload that car however you've built it. And then when you say transcoding behind the scenes, we're making various versions of that car, really, with fewer and fewer triangles?
Yes, that is correct. Or up, actually, in the future.
Yeah.
And so we have this capability now that we can, depending on the improvements of the engine and compute power that we have, we can improve the representation of number of triangles or texture maps or audio, video, animation, whatever we need.
So this is on demand. And I think what you were saying earlier, Sergey, is you used to have something called baking, like you would bake the high end. We're essentially baking on demand many versions of that car at various resolutions. They're all sitting there, and then the car way off in the distance I may see is one of those lower resolution ones. And this is, I believe, what we're calling transcoding.
Yes.
So how does transcoding work? Like, how do you take 1 million triangles and turn it into 1,000 triangles?
I mean, that ingestion. So to Studio, we actually ingest that 1 million triangle mesh. We then store it in our backend content platform backend system. And then upon request, we actually run LOD processing.
Which stands for level of detail.
Level of detail, which means depending on, we are trying to preserve as much quality for that limited representation of the mesh or texture.
So if maybe, Varun, if we thought about how this is working across devices, so Tsvetan, you're the creator. You put in this giant high-res car. I'm on a low-end Android device. You're on a high-end PC gaming device. Hopefully we can still play the same game. Like,
exactly,
what happens for both of us?
And so basically when my client comes online, it's like, hey, I'm a low-end Android device. I want this specific, because one thing we didn't mention, actually, it's not just about level of detail, but it's also a platform-specific representation. So Android, iOS, each of these different platforms have very specific representations that you can compress the textures. You can actually conform them in such a way that it works way more optimally. So my Android device will come online and say, hey, I want the Android version of a low-end texture for that tree. And then the Cloud Transcoding will go off and make that for me, and it'll cache it. So the next Android device comes online, it doesn't have to do it again. It can just send the version that I made. When your PC comes online, it's like, hey, I've got all the resources in the world. Give me the high quality version. Give me the uncompressed version. I just want highest fidelity. And then it goes ahead and caches that, which means that this is infinitely future-proof also.
And also infinitely instantaneous. So I love Grand Theft Auto, and they have like this new version that's going to be absolutely mind-boggling, which I'm really excited about. If I was an artist who wanted to adjust an asset in hopefully our future system, I would re-upload in about 5 seconds. Your and my game would trigger a new transcoding of that. And literally, at peak concurrency, like something like Grow a Garden with 25 million people, you could in 5 to 10 seconds have all of those new people possibly getting that new asset. This is why I think it's somewhat of the future, because I think part of the beauty of Grand Theft Auto is they bake in so much quality. They're going to put it on a giant DVD. They have to make sure that's perfect, and there is no way to iterate on that. You got to get it absolutely perfect right there. And so then I guess finally on the future proofing, in addition to instantaneous changes, there is something that seems good about storing artistic intent, storing the original work of art in a way. Can you mention how that might help us?
Since like we're trying to capture like as much original like artistic content like as possible, and like we're storing like for this like we're storing the source version
That's right.
of all the assets, and with this like as you can imagine, like we can not only like downsample it like by generating like simpler versions of a texture, but also upsample it like in the future, because like we already captured that semantic, that like what the original intent was, so we can upscale this asset in the future. So, and without requiring any user input, we can make it look better.
That's going to be a big hint as we get into the future. So let's add a second component to what we've been talking about. So we're streaming, make instantaneous fixes, cloud transcoding, deliver any LOD. And then what we hinted at the start, we're going to complement that with something called Slim. So Slim is not a workout program. It's not like the Roblox snacks that are hopefully going to make us all really feel good and think clearly. What's Slim in the context of the Roblox engine?
You have a tree, and as I said, like you might have like multiple trees like at the distance. Slim is what turns like all those individual trees like into a forest, and optimize like not individual assets like anymore, but optimize them like as something like that's bigger, that's aggregation like of individual assets. And it's the Slim technology, it's always optimized like those assets like in a specific context. So let's say you have like a building, right? So, and like a bunch of rooms inside that building. Like if you're outside the building, you don't care about the rooms inside the building. So, and Slim is aware about this context, like, and it can very efficiently remove all the building internals, like in that case, and generate like a very optimal version of that asset for you.
So there's three use cases that as you've been designing this, I've been thinking about. So one use case is people are building more and more complex avatars, and historically on Roblox, we've been very careful. How many layers of clothing can you wear? How much jewelry can I wear? How much stuff? But the future, maybe avatars have many, many things, like 100. And I think our creators are very savvy around performance. They may actually constrain the fidelity of avatars because they want so much perf. So avatars that are complex, number one. Number two, as you mentioned, there may be 100 trees over there, and they're way off in the distance, and no one's interacting with them. And then the third is maybe a building with rooms inside. I think what we're going to try to do here is, no matter what it is, a moving avatar, a bunch of trees, or a building, this exact same system is essentially going to composite down into a single object, single mesh, single texture. And that's absolutely mind-boggling.
Yes, you're exactly right. So that's a good word like for this. Like that system is dynamically generate like a composite representation like of multiple assets, like and it determines like the boundaries of this composition, the level of details like for that composition like dynamically. It's always operating like in this like world context. So exactly the same assets like in two different experiences like might be optimized differently, based like on the target device, based like on the context like in which they're used, like and We also support dynamic updates like for that content. So it's not always like, it's not like a static optimization. If something is changing like over time, this will be reflected like in the slim representation because like we can update it like dynamically.
It almost, one of the reasons I really like this is it almost feels if I was a Roblox developer and I really wanted massive scale and for example, really complex avatars, I might be dreaming of this. Like I can walk up to someone close to me, they can take their hat off, they can put on some new jewelry, which is the way this system's going to work with objects that are close, may work at regular high fidelity. And then as that avatar works away, it composites down into a single object. And as it goes further away with LOD, we joke like the ultimate is an avatar way in the distance, maybe 12 triangles and like a really small texture. So this is almost like what a developer, I think, has dreamed about. And then I think this makes, one of the things this makes possible is larger worlds across devices.
Absolutely. I mean, what Slim is essentially doing is it's giving us a new axis of scalability. So we talked so much about cloud transcoding and different levels of detail. Now we're adding another level of, another axis here, which is about composition. Right? And you can think about a 2x2 here, and any point on that is a valid experience. So you could be like high quality, low compositing. You could be high quality, high compositing if you're on a very low end device or a different device. And all of those points make sense. So if you're talking about a massive world, that entire world could be 12 triangles also if you're far enough away or if it doesn't make a difference.
And so then thinking about user experience and how Slim can lead into a better user experience. If we think about LOD, we think about cloud transcoding. If we think about Slim, we think about streaming. Relative to Roblox today or a year ago, how can this affect the user experience?
Yeah, so Slim, we built Slim with the idea that we are enabling the developers to create richer and bigger complex worlds that are going to behave and interact with the end user very easily, like without, and the end user experience is exactly the same as if you have the most powerful machine. And Slim is this system that today enables static models, and we are enabling in the future avatars and dynamic models that are generated hierarchically so that we can make the system as fast as possible for the end user.
Which for the end user may be more rich worlds on lower end devices. It might be on my low end phone. I can play with you on your gaming PC. Creators can make higher, not worry about the number of layers of clothing on an avatar, more complex vehicles, complicated mechanical objects as well are going to get compressed by Slim, which is going to be really, really cool. And then maybe thinking through how they work together. So we talked about cloud transcoding, so offering lower LOD. Then we talked about Slim, which is really lightweight models. Do they work together?
Absolutely, right? And that's what I meant by that axis thing. So all of the Slim models go through the exact same cloud transcoding pipeline as well. Because once you composite them, and once Slim is decided based on the context and based on the content, this is what the composite should be. It goes through the same transcoding pipeline and then generates a low quality version, a high quality version, an Android version, an iOS version for everything. So it's very, very much complementary between.
And so that really, for the creator, is almost like a double whammy. A very complicated avatar, way at a distance, composited into a Slim model, then transcoding. That avatar, once again, could be 12 triangles and like a single color.
And what you'd hope to see, or what I would expect to see, is kind of a first order. All of the existing experiences can just start to run on lower and lower end devices.
Yeah.
But the really exciting thing is the second order effects, right? Creators start to realize, like, oh, I can put more stuff into the world. Oh, I can add more to my
you think
avatar.
about it, if I'm building video, it's almost as if the camera is pretty thoroughly designed. You know, I get my 4K camera, and I never worry, like wherever I point the camera, can I take a movie? Like I do. But our creators don't have that camera today. Like if they point the camera in the wrong place, their world might blow up, right? Like too much resolution. Like if they point the camera at a crowd of 10,000 people, it's like, so this is almost like freeing up the immersive 3D camera.
But giving creators freedom. So we can do platform expansion and then genre expansion.
And I do think there is a time, we do not know when. It is some mixture of Moore's law, compute, slim, 3D streaming, AI, local tech, upsampling, whatever, where it may be that this camera is no longer a limitation, where if you wanted 100,000 people in a giant stadium, photorealistic, hanging out with your friends, streaming on a low-end device with your low latency, like feels good, that will be, I think, when we say the immersive 4D camera is mature. The good news or the bad news is there's a lot of work to do, so it makes our jobs kind of interesting. And I guess in that theme of how fast we're moving towards that ultimate 3 and 4 dimensional camera, Sergey, what's next for Slim, and like what would we optimize after this?
So for Slim, like a few big steps like in front of us. Like so, the very next step is like to make Slim fully dynamic, like support like avatars, moving vehicles, like moving mechanisms, and all that stuff. But the more important step after that, like, is to make Slim hierarchical. As Varun mentioned, like that Slim generates like pretty much the same assets like as like just regular assets. They go through exactly the same like streaming pipeline. We optimize them because like each Slim model has like individual LODs like and stuff. But like, what if we can take it like even further? What if we can combine like multiple Slims like into one like like mega Slim, and then again and again, and like in like this like fractal like way.
So this was part of our design question, because when you originally proposed Slim, we were looking at avatars, and we had a separate project thinking about how would you put 100 avatars together, and how are we going to simulate 100,000 people in a stadium? And what was really, there's this fascinating day when I think you said, you know what, we may be able to take Slim avatars and then put 100 of them into a collection of 100 avatars with exactly the same technology. And that's a little bit where we said, mind blown, like that hierarchical nature.
Yes, that's exactly right. And if you take this example to the extreme, right? So you can think about like, okay, so our like virtual camera, you can see the entire planet. So we see the entire planet, and it's like just like a sphere, like with a texture. When the camera gets closer, you will see like individual continents, like then you will see individual cities, and then you can go all the way down like to the stadium full of people, because like we have all the simulation running on the server, and client doesn't need to know like about like the entire world. It's clearly like you cannot fit like this entire planet into a device memory, even if you're on a powerful PC. But our servers like are very powerful, and by generating this like hierarchical representation for Slim, like we can go like from a planet scale all the way down to the like like room scale, like, or even like micro world.
Well, right. We may go all the way down to the watch that you or I wearing, looking at the little knob on the watch, and even further than that. And so then, as we think about this, then, Tsvetan, how might this change what creators start to do, right? We're gonna hopefully get rid of the, oh my gosh, I have to worry about the performance of an avatar. Any other changes you think we might see?
This will remove, in my opinion, all the limitations that they have today. They, as you said, they don't have to think about how complex the world they are creating. They just have to think about what they want to present as a game dynamics to their players, nothing else. Everything else is going to be handled by us automatically.
So, diving into some of that automatic stuff, there in the old traditional Roblox, we did this thing called texture reatlasing. We actually had a template for a texture, and you would have to figure it out. I'm assuming with a Slim model, that's completely automatic, like the generation of that texture at lower resolution.
Yes, that will be automatic, as well as determining those building blocks that Sergey explained in the hierarchical dynamic world.
Okay, so now we're really going to blow our minds, and we're going to talk about. It's easy to imagine something being simpler, right? It's almost like if you're an artist, it's very easy to imagine kind of making it more crude and flattening something out. It's a lot harder to imagine something getting a higher resolution. And so I want to poke a little bit into the future of AI. And There's a lot of work right now on AI, like how we're going to generate video games and real-time immersive streaming and world model and all of that. And I feel more and more we're going to find this is not a monolithic thing. This is going to be a stack of 3, 4, 5, or 6 models all working together, including, a command line where if we're hanging out, like we do with 4D, we can just say, turn the Washington Monument into Godzilla, and boom, it's going to happen right there. And ultimately generate objects or worlds or full games, and hopefully in a multiplayer context. So we're walking around together, the 4 of us, and we're saying, hey, over there, the 4 of us would like to design a new game and have it all magically appear. There's a secondary aspect in addition to command prompt and world gen and 3D, which is what you were saying, is upsampling. And that, if I imagine sometimes classic Crossroads, which is a 20-year-old game on Roblox, there's actually enough information there. If we took classic Crossroads and Sergey, you said, make this look like a photorealistic medieval version where the gameplay could be the same, all of those fun little rocket launcher tools are the same, but all of a sudden everything has a new look. So how would this work in the context? I don't know who wants to jump in on LOD, because now LOD has to go up rather than down.
I think one of the points that Sergey made before, right? It's about storing as much of the original artistic intent as possible so that we can do some of this stuff in the future. And my favorite example, and this is a random example here, but imagine I'm using a texture, but that texture was actually a picture that someone took. If I actually stored the aperture size, if I stored the f-stop when that picture was taken, now my upraising algorithm has so much more context. Yeah. If I know where that texture is being used, if I know that that's being used on a castle, is that being used on the floor, my upraising algorithm can be so much smarter about making that and keeping that original creator intent all the way through on that high-end PC or some future PC that's never even been invented yet.
So we showed this at RDC. I think we showed like a 15-second video of Crossroads being upsampled. Let's talk about what might actually happen. The asset is in the cloud, the 3D objects, the textures. There's an additional prompt sent into our content system that says, look, all of these assets are part of what should be a much more photorealistic medieval world. One can imagine then all of those different LODs being regened to be much more close to the photorealistic version by what we would call it a 3D upsampler, or really a 3D generative creator. So who wants to dive in on what might happen to the castle, for example?
I think like what Varun just mentioned, since like we're capturing like so much more like semantic like from that world, like that's like what extremely important. Like, so for example, for this like crossroad example, right? So if you look at the castle from a perspective of individual assets, it's just like, like a number of blocks. Like you cannot make like those blocks look any better. And the castle is just, it's more than just like individual blocks, it's a sum of them. And Slim, since like Slim operates like in this like context, Slim is aware about this thing like as a whole. So, and now like any upsampling algorithm like will know like way more like about, like a castle as a whole, not about like individual assets. So it can make like a way more better version like of that upsampled castle, because like it just understands that.
And in a sense, one could imagine without having that existing Crossroads castle, and just so everyone knows, Crossroads is a very old blocky looking Roblox game. That castle is actually a really good aid to the prompt. Build me a castle over there is a pretty open-ended prompt. Like, we're going to get a random castle of a random shape. But the castle in Crossroads actually dimension, size, like that's a lot of good prompt information to upsample into really a high quality castle.
Yes, that's exactly right. So because like this like 3D dimensional part of the castle, first of all, it's can be like very important like from a gameplay perspective, right? So you cannot just generate like any castle like and make it work like for the game, But if you can capture like all the like dimensions, like all the like semantics, like in all the context, like in what that asset been used, then you can upsample it like very efficiently. and you won't break like your game like by doing this, like because like that's like another very important thing. You don't want to upsample an asset like and make your game like unplayable.
Well, I think there's a future world where, in addition to all your 3D information, you can either be editing your 3D information or editing your prompt. They both come together to generate that world. So the 5-second update we talked about, which is an asset modification, in the future, it may be a 5-second prompt update and a little more hint in the prompt, and then lazily generate that world on demand. And then I think there's one last, when we think about all the dimensions of how AI can come together to bring these things photorealistic, there's a final layer, which is the 2D layer, what's happening on your gaming PC, what would be happening in some video appliance in the cloud, where even higher upsampling may occur. So for example, perfect hair on my head, the best place to do that hair may be locally with a 2D upsampler. I know you've worked on a lot of games that try to do hair in 3D. Do you think someday all hair will be done with 2D upsampling, or will it be 3D hair?
Yeah, absolutely. I think like we're moving like into that direction, because like some things like you can only do like in screen space. Like it's more efficient. Like let me put it like this: it's more efficient like to do in a screen space. Like for example, like this hair like rendering, right? So a lot of game engines like today doing like ML based like upsampling, like going like from like 1080p like to 4K, but you can do like way more than that, right? So you can change the shading, you can change how the things look, and if you take this example like to extreme, like a game engine can just render, like some like semantic information like for like ML algorithm, like, and then this ML algorithm like will generate, like good looking hairs, like, or good looking materials like in screen space directly. Super
good. So then as we start to wrap up, maybe for all of the C++ coders out there, the assembly language coders, which I wish I was like, that's one of the most fun things in the world. We're doing something very difficult here, right? We're trying to make all of these technologies run on all devices. Question on transcoding. And the question on transcoding is, I know a lot of PCs have optimizations with SIMD registers and things like that to make these things run faster. Have we started to probe around with SIMD in any of our transcoders, or is that future optimization?
So first of all, by the way, transcoding can run on engine as well today.
Okay, excellent.
Assets.
Good.
So we are taking advantage of SIMD optimizations, but we are looking even further than that using GPUs and other.
So yes. Transcoding on GPUs is coming, possibly.
Well, yes, we are looking into it.
Okay, which is super, super fun. Okay, so great update, everyone. For those who want visual, possibly RDC main stage presentation. I think we had visuals of a lot of this. Everything we've talked about is on the pipeline. We're watching it carefully, and I really do think all of you and the various teams behind you are really contributing to what would be what I sometimes call Game Engine 2.0, which is heavily cloud, heavily supported by transcoders and all of this technology. So thank you all. I think we blew everyone's mind today. Really appreciate it.
Thank you.
Okay, so hey, this is Dave. Once again, Tech Talks, and we'll look forward to seeing you our next time around. Thank you for the whole team. Thank you.